Okay, this one says find the average rate. So I saw the word average there. I also saw it there. So I require 2 points of change of the function over the given over. It's the same thing as between the given 2 points. That means this one is x1, this one is x2. But the way we love to write it, we want to write it this way. This is 2 for x1. Separate it, close the bracket, and then you want to put x2 on its own. That is 3, semicolon. You want to get your f of what? Substitute the 3. It will be f of 3, that one, which is actually our y2 in a sense. I'm just trying to show you how to use this language. This one will be f of 2, which is basically our y1. All right. So put 2 here. When I put 2 and I cube it, it's 8. 8 plus 1 is 9. So y1 is 9. There we go. And then put a 3, cube it is 27. 27 plus 1 is 28. So you get 28. So now all we need to do is to take 28 minus the 9. I'm not going to write it down because you know what's happening. 28 minus the 9 divided by 3 minus the 2. And then you'll get the answer. You can see denominator is not 0. We good, right?
Yeah. Yes.
Okay, good. Now there is something I want to emphasize here. This is the one I'm gonna, let me go after it because I saw it here. Where is it? Yeah, there it is. Yeah, let's go. Let's work with this one here, the cot. Now remember, you guys, whenever you're dealing with a pi, when you're dealing with pi, your calculator must be in radians, isn't it?
Yeah.
Yeah.
Yes.
Yeah. So you can keep it in degrees and convert it, or in radian one time. So let me see this one. I think I go mode. No. I think I go setup. Yeah, there is 0 there. And then radian, which is 1. There we go. Yeah, there we go. Yeah. So it's already in radian. So we're using cot. So so the first x value is this one. This is x1. This one is x2. So I'm going to write cot of pi over the 4. All right. So if they really give you this, and if you're not using a calculator, they're actually special angles. You understand?
Yes, 45 degrees. Yeah.
Yeah. Let me draw the Cartesian plane like that. Here we normally call that 0. We call this one 90. Am I right?
Yeah.
Which is actually pi. Am I right?
Yes.
And then we make this one 180. I'm going to come back and show you how to do it. And then this one is 270. And then the next one is 360. 360, we call it what? 2 pi, isn't it? Yeah.
Yeah.
So what you are doing, you're adding half. I mean, you're dividing by 2, isn't it? Am I right?
Yeah.
In other words, you're adding, remember, this is 1 pi.
And it's not pi over 2?
Yeah, it's pi over 2 here.
Is it not at 90 degrees? 90 degrees is
pi over 2. Yeah. Sorry about that. Yeah, pi over 2. Then we add, I was saying half. Then it's half pi. That's what I meant. Then you add another half pi here. Am I right?
Yes.
Then it gives us a pi here. Yeah, thank you. And then you add another pi, which is 1.5 or 3 over 2. Am I right?
Yes, you're right.
3 over 2 pi. We add another one, which is 1, which is 2, which is just 2 pi. Yeah. So there it is. Those are special angles. Now, I'm just going to do it this way. So I go with this one, the definition of that one. I write pi radian. 1 pi radian equals to 180 degrees. As my definition, instead of using that one of 52 point whatever. Then my special angles, like normally you guys, you use 30, you use 45. I know these are special angles. I already know that. Yeah. And then the 60. Then you're like, wait a minute. If 180 is actually pi, what will be 360? Well, you just take 360, divide it by 180, and then you multiply it by pi radian. We good, right? Yeah. Think of it's I know 3 times 6 is 18. I'm actually getting rid of 0 here. I'm getting rid of 0 here.
Yeah.
Yeah. So that I've got 3 divided by the 18. 1/6. That's what I was trying to tell you. So 1/6 pi, it's actually that one there.
45,
yeah. Then 45, it will be 45 divided by 80. There we go. Huh? Oh yeah. 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 That's right. I put the wrong thing. I put 80 instead of 80. Yeah. There is this one over the 4. So which is that one, the 45. Can you see that?
Yes.
Yeah. I was just trying to show you how they are. Then the other one, the 3/4, it must be this one, the 60. It has to be, because I can recognize it. It's one of those things there. Oh, it's 1/3. 1/3. Okay, we'll just pull out the other one. So this one is gonna be pi over the 3 radian.
Yes.
Yeah, pi over the 3, a third radian. Yeah. All right. So cot, remember, it's close to tangent, isn't it?
Yeah, 1/10.
Oh, yeah. All right. So you know this one. Yeah? So it's 1/10, and then you're having pi over 4. And then remember, this is like 45. I know tangent of 45 is 1. Come on.
Yes.
When you flip 1, it's still going to be 1. All right. So we know that I'm going to write it with blue. This one corresponds, I want to put it correspond with y being 1. That one there. And then look at, can you see this one is 3? Is 3/4. That one, it was actually it was actually 1/4.
Yes.
What I'm saying, the special angles that you have, the special angles, like with the, let's take this one with the 3. It's 1/3 pi. What they normally do, because it's 1 at the top, they increase the number at the top. They say 1/3, 2/3, and then 3/3, and then 4/3. You know, you're still dealing with the same special angle. So if they give it to me as 4/3 pi, I factor it out so that I have a 1/3. So I said, oh, well, wait a minute, this is the same as 4 into 1/3 pi.
Yes.
Did you get what I'm saying with that?
Yes.
Yeah.
Yes.
So I can actually do it that way, because I'm not too sure if they're gonna give you these ones here. Did they give you something with this?
Yes.
With these special angles here?
Yes.
All right. Okay. So that means you have to think in terms of let's go to the basic one. The basic ones, if I have, let's just take the simple one. Let's say I've got sine of 30 degrees. Sine of 30 degrees, you know, basically it gives me a half. We good, right?
Yeah.
Now, how about sine of 60 degrees? Now you're like, okay, we know it's √3/2, but you could say, now wait a minute. This is the same as 2 times the 30. Can you see that? Yeah.
Yeah.
Yeah. So you could. I'm going deeper now. Are you using double angle as yet?
Yes, we have started using double angles.
Yeah. So that means you can go with the double angle here. Unless if you double it, like as we doubled the 30, it gives me the 60. Can you see that? Yeah. All right. Or you just simply, if it's beyond those things, you just look at which quadrant does it lie in, and then you will go like a 180 minus, in your case, it will be pi plus pi minus, it will be reduced, it will be reduction formulas. Are we happy on that? I'm not working on it now, all right? I'll show you later on. The idea, what I'm saying, what I wanted you to remember, when you're dealing with the trig ratios, you deal in radians. That's what I was saying. I was saying that. I wanted you to remember that. And number two, I wanted you to remember that you're dealing with special angles. All you need to do is to get x1, y1, x2, y2, and then you just do the average gradient method. You get your answer. As simple as that. Are we happy on that one? Yeah. That was the key I was pointing out here. All right, working it out, we'll show. Now this one. Okay, let's separate this one. Let's put it on its